Okay, our second question. Determine the pressure for the water at 200 degrees centigrade and a volume of 0.4 cubic meter per kg. As in a previous lecture, I did say the first table you would be looking at would be the saturation table. If the property is greater than the saturation table, like the pressure is greater than, less than the saturation and the temperature is greater than the saturation, then you will be looking at the superheated table. If the temperature is less than saturation or the pressure is greater than saturation, then you would be looking at the compressed region. So first thing first, you have to look at the saturation table. Now, the in saturation table of temperature table 200 degrees centigrade, we have to find the volume. So let's check the volume at temperature 200 degrees centigrade. So if you can look at this thing now, so this is actually our temperature. Temperature is 200 degrees centigrade, and let's check the volume. Our given volume is, let's check it, which is 0.4 cubic meter per kg. So 0.4 cubic meter per kg at a temperature of 200, our volume is greater than Vg. So that means like if we are greater than Vg, so we are in a superheated region now. So let's check the superheated steam table now. So if you look at the superheated steam table, let me check it. Yes, so we have got a superheated steam table over here, and obviously there is actually the temperature at the top. So temperature at the top is somewhere here. Now the first value is of the volume, and we have to find the volume of 0.4 cubic meter per kg. So just move downward, as actually you can see like when we are moving downward, the volume is actually reducing. So just go downward there and keep going, keep going, keep going. Yeah, over here actually, somewhere here. So you can check at 200 degrees centigrade, we have got the condition in which over this point, I'm saying we have got the condition in which the volume is 0.4250, and we have got the condition in which the volume is 0.3853, corresponding to the pressure of 0.5 megapascal and corresponding to the pressure of 0.55. So our pressure, our volume, which is actually 0.4 cubic meter per kg, is definitely not there. So that means like our volume 0.4 is somewhere between a pressure of 0.5 and 0.55. I hope you got the point. So let me rub it out. Okay, so it's been rubbed out anyway. So let's now let me take a snapshot of this one again, so it would be easy for me to uh, just paste it there. Um, that's the one actually, and let me paste it in a new table, a new page, and that's somewhere here. So what we have got over here, like we have got a pressure of 0.5, pressure of 0.5, pressure of 0.55, corresponding to, and we have got the volume which is actually 4.52, 0.4250, and a volume of 0.3853 at a temperature of 100 degree centigrade. And we have been asked to find the pressure at a volume of 0.4 cubic meter per kg. So we have to find a pressure which corresponds to a volume of 0.4 cubic meter per kg. So same thing what actually we have done in a previous example, what actually I have said. So we have got a pressure of 0.5 megapascal, corresponding to that 0.5 megapascal, we have got a pressure of 0.0, sorry, we have got a volume of 0.4250, and we have got a pressure of 0.55. Corresponding to that, we have got a volume of 0.3853, and obviously at 0.4 volume we are looking at the pressure. So same would happen, and that would be pressure. Let's suppose again slope formula we will be using. So 0.55 minus 0.50 divided by 0.3853 minus 0.4250 should be equal to P minus 0.5 divided by 0.4 minus 0.4250. You might be looking at this thing would come up as negative, like the bottom bit anyway, both of them. So you can check it like when it cross multiply, the negative sign will go on, and then you would be having a positive value. Solving it, and obviously you will come up as like solving it in this example, it will come up as 0.5, and that's in kilopascal. So it will come up roughly at 0.53 something. Make sure you solve it in your own calculator. So this is what actually the interpolation would look like. Now we have got another problem, and that's what we call it as double interpolation. And that double interpolation, that's quite a different difficult concept, but yes, not so difficult anyway. um, let's check what actually the double interpolation look like. Sometimes double interpolation is needed, for example, to find the specific volume of a, let's say we will have an example, specific volume of 21 bar, sorry, specific volume of a steam at 21 bar pressure is there, and at 360 degrees centigrade. So let's check it. It's a like we need to find a volume at pressure which is 21 bar, and a temperature which is actually 360 degrees centigrade. Make sure you first convert this table or this thing into, make sure you just convert into bar into megapascal. So 1 bar is equal to 10 to the power 5 pascal, and 1 megapascal is equal to 10 to the power 6 pascal. So if you just divide it, so that means like 1 bar would come up as 0.1 megapascal. So that means like 21 bar would be equal to 2.1 megapascal. So make sure you just convert it to megapascal because your own steam table is in megapascal. So again, let me check the steam table again, and we would be looking at a steam table of 2.1. Yes, sorry for that. That we will be looking at 2.1 megapascal and a temperature of 360. So let's say go down there, and make sure that I presume like we are in a superheated anyway, but make sure you check. So we have got a table of 2.0 megapascal. We have got a table of 2.2 megapascal, but we do not have got a table of 2.1 megapascal. That means like we do not have got a pressure which correspond to 2.1 megapascal. Now let's go to the temperature as well. The temperature which actually is required is 360. Now look at the steam table. We have got a temperature of 350. We have got a temperature of 400, but we do not have a column, which means like we do not have a column of 360. So let's make it easy. I did something, I'll make a calculation, and then I said like let me find this thing uh, from the steam table. So that means let me rewind it again. So I have got a pressure of 20 bar, which is to 2.0 megapascal. Corresponding to that 2.0 megapascal, I have got a temperature, a volume at 350, and I have got a volume at 400, which actually I would show you again. So that means at 2.0, I have got a volume of So at 300 at 2.0, I have got a volume at 350 as well, 400 as well, but I do not have got at 360. So just same thing over here. I've got at 2.0 megapascal, I've got volume at 350, 400, but I do not have got a volume at 360. Similarly, at 2.2, I have got a volume at 350. I have got a volume at 400, but I do not have got a volume at 360. So what that mean actually? So for interpolation, if you remember, for interpolation we must have got the two extreme values. What I'm saying, like, if I need to find a volume at 360 degrees centigrade and 21 degrees centigrade, either I would have a volume known at this point and this point. That's because I have got the two extreme, or I have got the volume should be present at this point and this point as well. So that means, like, if I am interpolating between two values, which mean like interpolating them, so like 350 and 400 actually, so I must have got them two extreme values as well. So I do not have got any value written over here. So what I'm trying to say is, either you need to find out the volume at this point, and then obviously interpolating between them two value, or you need to find out the volume at this point and this point, and then interpolating between them two value. Let's check if we can find it. Okay. So first thing first, what I can do actually, let me take this example somewhere to the other page so we can solve it over there. Okay, now let me put it in a blank one. So what I can do, like, at 21 bar or 2.1 megapascal, let me find it, like, at 21 bar I do not have got anything over here. Well, let's check it in the other direction. At 2.0 megapascal, the value of 350 is given, volume value I'm saying 0.1386, and the value of volume at 400 is given, which is 0.1511. Now, to find out the value of volume at 360, I would do the interpolation between 350 and 400. So what actually I mean to say, like, 400 minus 350 divided by 0.1511 minus, sorry for that, minus 0.1386 should be equal to 360 minus 350 divided by volume, which need to be find out, minus 0.1386. So solving this one, I can find at 2.0 megapascal, I would find the volume at 360, and let me call it as V1 actually. Is it okay now? I hope. Then at 2.2 megapascal, 22 bar, let's say 2.2 megapascal or 22 bar, same thing would happen. At 350 I've got a volume which is actually 0.1255. At 400 I've got a volume which is 0.1370. So I can find a volume which is at 360. So I can name it as V2 now. I hope that is understandable now. So just leave this thing now. So now what I'm saying, I have got a volume at two extreme position now, and I need to find this volume. What my actual calculation would look like, or what actually I mean to say, is at 360 degree centigrade, the volume at 2.1 megapascal is given. Sorry, at no, sorry, it's not 2.0, 2.1, sorry, 2.0 megapascal is given, or we did find out, which is V1, if you remember right now. At 2.2 megapascal, we did find out the volume at 360. If you remember this one, we have got to find volume, which is V2 now. So now, what I'm saying now, at 2.1 actually, I would find the volume, which is actually the required volume. I hope you understand that one. If you're not, can you please skip it back, and obviously that would be easy for you to understand now. So this was actually what we call it as a double interpolation, and this is what actually it would be. So what we need to do, like we need to find one of the column first, or the row. Then we did find the second row. But I'm saying, like, I did find at 20 bar, I did find at 360. So I've got a volume which is 0.1411 somewhere here. At 22 bar at 360, I've got a volume which is actually V2, which is over here. Now I've got these two value extreme now, this value and this value. I can find the other value at 20 bar, 22. We have got the volume. I can find the value at 21 bar, which is somewhere here. Thank you very much. This is end of lecture 4.0, and let's proceed to lecture 4. Lecture 4a, and let's proceed to lecture 4b. Thank you very much.